I'm now going to teach you some of the Python language basics. So let's start with values. Python has 4 primary kinds of values: integers, floating point values, Boolean values, and strings. So there's no great surprises with integers, floating point values, and Boolean values. Strings can be enclosed either in single quotes or in double quotes. And depending on which kinds of quotes you choose, you can use the alternate kind of quotes within the string. So here we've got a string enclosed in double quotes, and we've used a single apostrophe within the string. I'll then show you some integer operations. So of course Python supports all of the usual integer operations you'd expect in a programming language. Here's some of the quirks. The division operator, when working on integers, returns a floating point value. So 7 divided by 3 is going to return 2.333 and so on. And Python gives you about 15 decimal places of precision for floating point values. If you want integer division where the result gets truncated, there's a floor division operator which is 2 forward slashes. So 7 divided by 3 is going to return 2. That's the value 2.3 rounded down. The remainder on division operator is the % sign, just as it would be in C. So here we have the remainder of 7 divided by 3, which is 1 of course. And star star is the exponentiation operator. So 2 star star 6 means 2 raised to the power of 6, or 64. Python then contains a whole range of built-in functions. There's lots and lots of very useful built-in functions. I'll just show you a few of the most useful ones. The round function is used to round floating point values. So here we're rounding the value of 6.66 to 2 decimal places, returning 6.67. The str function can then be returned to convert any value into a printable string. So here we're converting a floating point value into a string representation. And if you literally type str 45.67 in at the Python shell, you'll see this string being returned. There's a similar function int that converts a string value back to an integer. So here the string 999 is being converted to an integer value, and the decimal value of that integer is then being printed out. And there are similar conversion functions to convert between any of Python's 4 value types and other value types as well. There's also functions to convert values to different number bases. So here we've written a decimal number 255 and we're converting it to hex, and that will then return the hex value as a text string. And there are similar functions for binary and octal. Python also contains lots of built-in string operations, and keeping with the spirit of batteries included, there'll be operations in Python to do anything that you could reasonably want to do with strings. For example, you can concatenate Python strings using plus as a concatenation operator. You can also write multi-line strings extending across many lines. So multi-line strings have to start with 3 quotes, either single quotes or double quotes. The string can then extend over many lines and the string is closed with another 3 quotes. There's also a built-in function len that returns the number of characters in any Python string. One very common and useful string operation is the index operation. The index operator is like an array index in C. It's a value enclosed, an index number enclosed in square brackets. So here we've got a string, A, B, C, D, E, F. That string is an object that's been bound to a variable s, and we're then using the index operator on that variable. So S0 is going to return the first character of the string. So arrays and strings in Python are always indexed starting from 0, as they would be in C. So S1 is now the second character in our string, B. S-1 is the final character in the string, so you can use a negative index to start counting backwards from the end of the string, which is very useful. S-2 then is going to be the second to the last character of the string, or E in this case. Python also supports slicing. A slice in this case is part of a string. So here again, S is the 6-character string A, B, C, D, E, F. S2:4 is a slice of that string where 2 and 4 are the start and stop positions of the characters in that slice. So the slice starts at character 2, that's 0, 1, 2, character C, and the slice stops at character 4, and you can see that the stop index is always the index following the final character in the slice. So the slice here, 2:4, actually consists of 2 characters, C and D. The start index points to the first character, the stop index points to the character after the final character in the slice. That takes a bit of getting used to, but there are some advantages once you get used to it. And there's defaults for the start and the stop. So if you miss out the start, it defaults to 0. So S:3 is going to give us a 3 characters index 0, 1, 2. The stop defaults to the length of the string. So S3:blank is giving us 3 characters D, E, F, the final 3 characters in the string in this case. And as well as a start and a stop, a slice can also have a step. So S1:6:2 is giving us a string that starts at position 1 or B and then moves down the string in steps of 2, stopping before it gets to position 6, B, D, F in other words. Slicing is very useful. We'll come back to this idea later on. So in Python, all values are themselves objects in the object-oriented programming sense. And that means that we can use values as the basis for operations. The slice operation, for example, or the index operation doesn't have to be done on a variable, it can be done on a raw value. So here we've got a string A, B, C, D, E, F, and we're then using the index -1 to select the final character of this string. You can see F being printed out. Similarly, we can slice a value directly. So we're slicing this string here to print out the 3 characters A, B, C. Strings also have methods, where I'm using the term method in the object-oriented sense to mean a function that's associated with a particular object. Because this string is an object in Python, we can call its upper method, and the upper method will convert all of the characters in the string to uppercase, and you can see here we're printing out an uppercase string. So Python has all of the methods that you might expect it to have for manipulating strings. For example, we can search for strings within other strings using the find method. So here we're trying to find the string CD within the longer string A, B, C, D, E, F, and find will return the index number of the first character in the string that it finds, index 2 in this case. Of course, in Python you can break stuff just as you can in any other language. You can write code that goes wrong. For example, let's suppose we try and find the string GG within the longer string A, B, C, D, E, F. Of course, that find is going to fail, and what will happen in this case is that find is going to return the value -1 to say the string can't be found. Suppose we try to index off the end of a string. So if we write A, B, C, D, E, F index 6, where index 6 doesn't exist, then in that case, what Python is going to do under the hood is to raise an exception. Python has exceptions just like other modern programming languages. So here in the Python shell, we can see a traceback, which is printing out what's gone wrong in this case, and we can see that the exception that was raised was an index error to say that the string index was out of range. Python also supports control statements, as you'd expect in any programming language. And in fact, Python has the usual range of control statements, such as if statements, for loops, and while loops. And all of the control statements can be nested within each other, just as you would expect in any modern programming language. The way that Python does this is rather unique, however, because Python uses indentation to reflect the structure of the code. There are no begin-end statements in Python, nor do we use curly braces to group statements together. Instead, statements are grouped together by indenting them and writing the group statements at the same level of indentation. So here at the top we can see an if statement nested within another if statement. So again, to highlight what's going on, whenever you see a colon, that's an indication that we're jumping to a new level of syntax. So on the following line of code, we have to see a new level of indentation, which needs to be exactly 4 spaces. And by always using 4 spaces as indentation, it means that Python code is intrinsically well structured and pretty printed. Of course, Python has the usual range of operators, so we've got comparison or relational operators such as less than or greater than. We've also got and or operators for executing Boolean operations. So here we're saying if C is less than 0 and D is greater than 0, then assign B to 2. If you want to nest conditions, there's an elif construct. So this says if A is 0, do something, else if A is greater than 0, do something else. And then there's an else, as you might expect, if none of the above conditions match. Then, as well as the for loop that we've already seen, Python has a while loop that loops while a particular condition is true. Again, using indentation here to indicate where the end of the while loop comes. There's also a break statement for jumping out of loops and a continue statement to jump back to the top of the loop, exactly the same as C. So in Python, break will jump out of the smallest enclosing loop, which is this for loop in this case, not the while loop, because the while loop ends with this outdent. Normally in Python, if you want to nest statements within a control construct, you start the nested statement on the next line, but if you've just got a single statement to execute, you can write it on the same line as shown here, which can be quite handy sometimes. So there really isn't very much to learn about control statements in Python. If you're used to other programming languages, they're very straightforward. The Python operators are pretty straightforward as well. Most of them are borrowed directly from C. So we have the same relational operators as C, similar arithmetic operators, although not totally identical. The bitwise and the assignment operators are borrowed from C, although there is no plus plus and minus minus operators in Python. The Boolean operators are the keywords and, or and not, which makes them rather more readable than the C equivalent. And then there are some special operators for testing set membership and identity between different objects. There's even a conditional expression, so we can use the if-else keywords within a Python expression as a conditional operator. So x equals A if B is less than C, else D plus E is exactly the same as this if statement near at the bottom of the slide. Let's take a closer look at range. Well, the most straightforward form of range I've shown you already, range 4, is going to take the 4 values 0, 1, 2, 3. In the print function here, we're printing out each of those values, and we've used a keyword argument end, so that instead of separating each value with a new line character, we're separating the values with a space character. So this is a very handy way of giving you some fine-tuning over the behaviour of the print function. Range can also take a second argument, which is the stop value, and this is analogous to the stop value in a slice. So range 2, 6 is going to return the 4 values 2, 3, 4, 5 in turn. And there's also a step value. So range 0, 8, 2 is going to start at the value of 0, then move up in steps of 2, 0, 2, 4, 6, until it stops just before the stop value of the range. And again here you can see that the print function has a built-in keyword argument, an optional argument that we can add to provide more information to the print function. And there's quite a lot of these optional keyword arguments in Python that it's worth you learning about over time. Talking of functions, you can of course define your own functions in Python, and that's done with a def statement. So a def statement defines a new function, and a function may have arguments, which are just variables listed on the first line of the function. And then the actual executable statements associated with the function are indented on a new line, just as for any other control construct. So here in this function, we're adding together the arguments p, q and r, which will return a new object that's bound to this variable temp, and we're then returning the value of the temp using a return construct. So in effect, Python allows us to declare and use functions with just two new bits of syntax, the def statement for defining the function and the return statement for returning a value from the function. And you then call a function just as you would in any other programming language. So here we're passing the three integer objects, 1, 10 and 100, into this function where they're bound to the variables p, q and r. We then execute the function and return a new integer object that will be assigned to sum. Now functions don't have to have arguments and functions don't have to return values. So you can define a function with no arguments simply by having an empty argument list, and you'd call the function like this with an empty argument list. Also, a function doesn't have to return a value, and if you don't return a value from a function, then instead of calling the function with an expression, you would simply call the function as a statement in its own right, just like a void function in C or some other languages. Also, Python has the idea of global variables. So variables declared at the top level here outside of any function are global variables, and you can see there's another syntax trick here. We've assigned three variables on a single line by separating both the variable names and the expressions on the right hand side with commas. And as in any block structured programming language, you can access any names declared in an outer scope within an inner scope. So here inside the function, rather than a, b and c being arguments to the function, we're simply accessing variables declared as an outer scope. Very straightforward.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. Watch the rest of John's webinar, Python in 1 hour, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.